advanced speech-to-text or ASR models like Ink2 can make transcription errors on unusual words. This can happen because of unusual spellings or where the pronunciations just don't match what the model expects. Let me show you on the Cartesia Playground. I'll use unusual brand names, human names, and food names to illustrate the point. So I'm going to click here. All right, when I was building my startup Whooshka, my Irish friend Siobhan introduced me to these Irish potato dishes called champ and colcannon. I thought they were delicious. Speaking of delicious, you really should try Raghav's dal makhani. As you can see here, the Ink2 model has to guess the spelling, as does any other ASR model, and it gets these uncommon words wrong. So for example, Whooshka is actually WH with 2 O's, right? And Siobhan is Siobhan, a very Irish Celtic spelling. And it's colcannon. I'll show you the spelling in a moment. And finally, it did get dal makhani right, which is a testament to the Ink model from Cartesia. But to get around this problem, Cartesia has added what's known as keyterm prompting. It's also called keyword prompting or custom vocabulary or keyword boosting and so on. Now, with keyterm prompting on the actual UI, it's pretty straightforward. You just copy and paste the terms here, right? So the first one I want is capitalized Whooshka. The second one I want is Siobhan, also capitalized. And the third one I want is colcannon. It's one word, right? That's how I want it. Now, when you add these words to the model to be aware of, it increases the model's bias towards transcribing those words exactly as you supplied. So in the playground, like I said, you can just type them here, and now we're ready to try it out. But when you do it in the docs, and let me switch over to the docs here, you will see that you just connect to the WebSocket API, which is already in the docs, pass in the model and the encoding for the audio, and then the key terms are just key value pairs of key term equal and the actual term that you want to give the model to bias it, and then key term equal to, in this case, it's Cartesia and Sonic and so on. That's it. Now, if you're doing phrases and you have a space in between, it's just classic URL encoding. So you can use an URL encoding library or just do %20 for the space. And if you're using the TypeScript or the Python SDK, then you can just add the key term parameter in the Cartesia WebSocket method. As you can see here, we simply add key terms, and we can do the same thing for TypeScript. So you can see that it's done that here as well. The key terms are simply just passed in based on what's passed in the function. And that way the list of key terms just gets sent to the WebSocket and through the helper method that we've exposed in the SDKs. Okay, now that we've added the key terms, we should expect that the same audio will transcribe correctly. So let's just try it. I'm going to click resume here, and I'm going to read the same thing out. All right, when I was building my startup Whooshka, my Irish friend, Siobhan, introduced me to these Irish potato dishes called champ and colcannon. I thought they were delicious. Speaking of delicious, you should really try Raghav's dal makhani. Now, this is really important because I didn't add dal makhani as my key term prompt before that. It's got it wrong this time, perhaps because of the difference in the way I said it. So I'm just going to add it here, and we're going to try just that bit again. And this is an example of a phrase that has a space in between. So in the URL, it would include a %20 sign. So let's try that. You should really try Raghav's dal makhani. Okay, and I got it right. So make your conversational voice AI agent much more robust by using key term prompting. Now, in the docs, we've called out that you can do a maximum of 100 key terms per single WebSocket connection, and all the key terms can sum up to about 1,200 characters, right? So these are some important constraints for you to keep in mind. It works across both the real-time speech-to-text and the auto, which is, the auto turn detecting, because Ink2 is extremely, extremely powerful. It is a state-of-the-art model, right? It has the built-in ability to actually do things like user turn detection, so whether users started speaking, ended speaking, or whether they pause speaking or have resumed speaking. So you don't even need a voice activity detecting model because Ink2 can do it all for you. So Ink2, you can find out more about it in the Cartesia docs. You can get the full API reference there as well. Okay, hope that was helpful, and thank you for listening. Please remember, do like and subscribe so that you can be notified of other videos. We're going to be doing a lot more of these, but also importantly, please send us the feedback. Tell us what you want to see. Tell us what you're struggling with. Tell us what you're really enjoying, and then we can actually get back to you, improve the product, help you get unblocked and so on. The best ways to reach out to us are in the comments or on the subreddit, which is an open subreddit, and anyone can ask questions there, or of course on Twitter and LinkedIn. We're always happy to hear from you, and we'll see you next time.